What's going on, everyone? So in this session, let's define what a tangent line is, and then let's figure out how to find the equation for a tangent line, okay? And so all this is going to be relative to functions that we covered in the previous video. And so if you need review on functions, go ahead and look at that video, okay, before you progress to this one. And so based on the functions that we worked on previously, a tangent line that we're going to define today is basically just a line that's going to touch a point on your function curve. Okay, and so let's go in and see if you remember. Here's a pen. So from last time, you remember this function, right? The function for a parabola, right, was defined as f of x is equal to x squared, right? And we learned that f of x and y are interchangeable. And so you can also write the same expression this way, and it means the same thing, okay? And last time we said that once you have something in this form, as a quick review, right, then you can plot your function to see what it looks like using a coordinate table. And so just like last time, let's define this function, right, or this function with this name, over the interval from x is equal to -3 to x is equal to +3, okay? And so what that means is we're just going to evaluate this function, right, from x is equal to -3 all the way to x is equal to +3, okay? And all we're going to do is wherever we see x, right, in our function, in this case, our function is x squared, we're just going to plug in these values, right, into here or here, same thing, and we're going to figure out what value of y we get out. So -3 squared is 9, -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4, and 3 squared is 9, right? And so remember how we said this, these are our coordinate points, right? Coordinates that we're going to use to plot, right? To plot our function. And so each pair, right, in this case, the first pair is -3, 9. The second pair is -2, 4, and so on for the rest of these. Plotting in our Cartesian coordinate, right, our xy coordinate that you see over here, is always going to be defined by the first input in here is going to be your x value, comma, the second value is going to be your y coordinate, okay? And so let's plot this up. So -3, 9, that's up here. -2, 4, -2, 4, -1, 1, 0, 0, 1, 1, 2, 4, and 3, 9, okay? And again, just connecting all of our dots. This is how, and this is supposed to be touching again, right? This is the curve of our function, okay? So I'll label this our function, right? On the interval from where x is equal to -3 all the way to x is equal to +3, right? And so going back to, or connecting this to the idea of a tangent line, right? A line that's going to touch the curve x squared, let's say it makes contact with this point right here, okay? Let's call coordinate 1, 1, right? Let's call that point A, and that's located at 1, 1. A tangent line at this point on our curve is going to look somewhat like this. Okay? And hopefully I'm going to use the stencil for it. So this is going to be our tangent line. And as you notice, right, it's only going to make contact right here. And so here is where the contact point is. And the properties of a tangent line say that, and I'll label this, right? At the point of contact, both the tangent line and our function curve, right, are going to have the same direction and the same steepness, okay? And the way that we're going to quantify this or put this in numbers, right, is we are going to, later on in a bit, we're going to talk about a concept called slope, okay? And so we'll discuss this in context, but if I were to ask you for the equation, right, if I were to ask you for the equation, find the equation of the tangent line to the parabola, right? To the parabola y is equal to x squared at point A, right? That we defined as coordinate 1, 1. So if I asked you to find the equation of this line at this contact point, right? So one of the general formulas that we're going to use to do this is called the point slope formula. Okay? And this is going to be a common formula that you'll use. So I would suggest writing it down or just getting used to using it. Okay? And it looks like this. Y minus y1 is equal to m times x minus x1. Okay, so this is the point slope formula. I'm going to put an asterisk next to it because this is one of the important things that should be taken away from this. Okay, and so let's break this down. Okay, and so in this case, x1, right, represents the x coordinate that you were given, right? So in this case, x1 is the x coordinate you were given. That's this, right? Y1 represents the y coordinate that you were given. That's this, right? And then m represents the slope that I was referring to above here, right? And slope is also known as m, so it uses the variable m in calculation. And remember we said that slope is going to represent the steepness and direction, right, of this line, of our tangent line at this point, okay? And so the way that we're going to calculate slope is there's a general form for it. So slope, right, is also defined by the variable m. And this is often referred to as rise over run. Okay? This is another central piece of knowledge that you want to take away from this, right? And I'm going to continue over here, but I just boxed this to show you that it's important, okay? And so the way that you're going to calculate rise over run, or the way you can think about it is rise, think about this as vertical change, and think of run as horizontal change, okay? An equivalent way of seeing it is going to be rise, or your change in your y, right, axis over change in your x direction, okay? So this, before I finish that box, this is going to be seen like this, right? So generally, in order to calculate your slope, you're going to have two coordinates, okay? So in concept, right, just separate, you're going to have one set of points, let's just say coordinate A defined by x1, y1, and you're going to have another coordinate, right, called x2, y2. And let's say you wanted the slope of the line that connects the 2 points A and B. This is how you would calculate the slope, okay? And so, as a conceptual example, if I gave you this plot, right? Beautiful straight lines. So this is your x, this is your y, okay? So I'm going to create a somewhat uniform grid just so you can see exactly what I'm talking about. Okay. And each of these boxes can be thought of as a unit, so like 1, right? Awesome. And then it'll continue over here too. And so this will be 0, 0. That's our origin. This is 1. This is 2. Down here is -1, -2, right? This is 1, 2, this is 3, okay? So assume that the line I'm going to draw right now is straight, okay? Actually, I can make that happen. So take this line, for instance, all right? So this line goes from, assume it goes perfectly from 0, 0, this corner, all the way to 3, 2, to this corner, perfectly, right? So this is the line segment. So when I'm talking about the steepness and direction, right? I'm referring to the slope. When we say that the slope, right, is the rise over the run, right, which is also defined as change in your y direction divided by change in your x direction, using this length here is going to be your rise, right? Because it came up 2 points. So your rise here is 2. Your run from this perfect corner to this perfect corner, you're going to consider this whole thing to be your run, okay? And your run is going to be 1, 2, 3, okay? So in this case, your rise is 2, right? Because you went up 2 in the y direction. And your x is +3 because you went to the right 3 times. So in this case, your slope is going to be 2/3. Okay? And so let's take this concept, right? And let's just say that I wanted you to find, right, the slope of this tangent line so that we can plug it into our point slope formula, right? So that we can answer this question, the equation of this tangent line to the parabola at this point 1, 1, okay? And so how we're gonna do this is, I'll write this out as our sort of game plan so that you know what we're about to do, right? So the first thing we have to do is find the slope, right? Find the slope, and then we're going to do that by approximation that we'll go into right after this, right? And then 2, we can plug in everything into our point slope formula, okay? So I'm gonna open up a new page and then I will write this out, all right? So let's reiterate here. So our function is f of x is equal to x squared, right? And we're gonna find the tangent equation for the tangent line at point 1, 1, okay? And so we said that your curve is gonna look like this, right? Okay? And 1, 1, let's say it was right here, right? We wanted the tangent line here. This is your tangent line. Now I'll fill in everything else to make sure it's familiar, okay? And then this is f of x, x squared. Cool. This point is A at 1, 1. All right? And so remember that our point slope formula, right? Or sorry, our slope formula typically requires you to have 2 coordinate points, right? Because it's defined by some second y coordinate minus the first divided by a second x coordinate subtracted by the first, okay? And so we only have x is equal to 1 here, and then y is equal to 1. So we only have one set of coordinates. But what we're going to do is, in order to get this second coordinate, right? In order to get x2 and y2, we're going to approximate. We're going to approximate very, very close to x is equal to 1, right? Because that's what we're given here. And we're considering x because our function is a function of x, okay? So we're going to approximate some value very close to our given function, our given value, x is equal to 1, okay? And we're going to do this on both sides. On both sides to ensure, right, that our slope approximation is correct. That our slope approximated value is accurate. Okay? And so let's come up with 2 values, right? So generally, we want to see if the slope that we calculate for this point is going to be accurate. So what we're going to do for our second coordinate is that first we're going to choose a point really close on the left side of this x value, right? On the left side of x is equal to 1. And then we're going to pick a side real close on the right-hand side of it. So for these purposes, let's first select, right? Let's first do our left-hand side approximation. So left-hand approximation, right? And we're going to choose x is equal to 0.999. So super duper close to 1, but not 1, right? And so remember, we chose x is equal to 0.999, and our function that we're working with, right, is this. You can also rewrite this, right, how we always have. Y is equal to x squared. So in this case, if x is 0.999, you're going to plug in 0.999 here, right? Same thing here. So 0.999 squared is going to be the value for y, equals 0.999 squared. And that's going to give you a y value of 0.998. 9, 9, 8, right? And so now with this, you have your x-coordinate and your y-coordinate for your left-hand approach, right? So this is going to give you, let's call this coordinate b, and this is going to be 0.999, that's your x, and 0.998, that's your y, okay? So left-hand side coordinate done. Now let's see the right-hand coordinate that we're going to choose, okay? So similar approach, you want to choose an x value that's super duper close to 1, but not 1. So for this, we're going to do 1.001, okay? And same thing, our function says y is equal to x squared, right? And so we're going to plug in our x value now, 1.001 squared, and that's going to give you 1.002, okay? Now based on here, let's call this our third coordinate. Let's call it c, which is going to be 1.001 as our x, 1.002 as our y, okay? So now notice that we have, right? So what we have is 3 coordinates now. We have A, our original, right? And then this is our first point. As our second point, we have B from our left hand approximation, right? And then we have C from our right hand approximation. And remember, we're trying to calculate the slope, right? Using points on the left and slightly to the right of our given coordinate, just so that we can approximate the slope, okay? And so let's do our work on approximating, right, the slope near point A, right? Not on it, but near. So let's do the slope between points A and B, okay? This is going to be change in y divided by change in x. Typically, it's y2 minus y1 over x2 minus x1, okay? In this context, let's rewrite this, right? Because this is going from point A to point B. So this is going to be the same thing as the y-coordinate for B minus the y-coordinate for A divided by the x-coordinate for B minus the x-coordinate for A, okay? And so let's plug our numbers in. So YB is equal to 0.998, 0.998 minus y of A is 1 divided by x of B is 0.999, right? 0.999 minus x sub A. So that's just 1, right? And so this is going to work out to negative 0.002, right? Divided by negative 0.001. And when you solve this out, you're going to get 2. So according to the left-hand side approximation, right, the slope of the tangent line, right, at, let's say, left and right. So in this case, the slope according to choosing our second point on the left, let's say it's right here, right, is equal to 2. So now let's see if the slope according to the selected point on the right agrees. So again, the slope between point A and point C this time, still the change in y over the change in x, right? Rise over run is equal to the second y minus the first one divided by x2 minus x1, right? This is the general formula. Now, specifically for what we're doing, right? The y-coordinate from B minus the y-coordinate from A divided by the x-coordinate from B minus the x-coordinate from A. So now let's plug our values in. YB, or this should be C, I apologize. There we go. Got ahead of myself. So this is going to be y of C minus y of A, right? Because we're finding the slope between A and C, not A and B, divided by x of C minus x of A. Okay, so now let's plug in what we have. So y of coordinate C is 1.002, 0.002, minus y of A is just 1, right? Y of A is 1, divided by x of C, this is 1.001, 0.001, minus x of A is just 1. This is going to be 0.002 divided by 0.001. Again, this is 2. So we find out that these two values do agree. Okay? So now we have confirmed, right, that the slope at point A is 2 because we checked at a point slightly to the left of this point and at a point to the right of A. All right, so now that we have our slope, remember our workflow, right, our game plan. Now we are going to take all of our information, so our function squared, right, the coordinate that we were given, and now we also know our slope, right, is equal to 2. And we're going to put all this into the point slope formula. Okay? Minus x1. And again, this is a major formula that you should kind of know, right? Because this is going to give you the equation of a line. Right? So point slope formula. Okay? And so let's just start plugging our stuff in. So x1 is 1, y1 is 1, right? Slope is 2. So y minus 1 is equal to 2 times x minus 1. So let's distribute the 2 in here, right? So y minus 1 is equal to 2 times x is 2x minus 2 times 1 is 2. Let's simplify this side. And now we're going to add 1 to both sides. Negative 2 plus 1 is minus 1. Okay? And so now this is your equation, right, of the tangent line. Equation of the tangent line, right, to the parabola at point A. At point A, defined as 1, 1, right? And just so you can see it, right? This was your parabola. This is y, this is x. This is your parabola, right? This was coordinate A, or 1, 1. This was your tangent line, right? The tangent line touches the curve at one point. right, at this point. And so this is the equation for this tangent line, right? So this is here, okay? And so do notice an additional thing, that the form of this equation of a line, okay? And so in addition to the point slope formula that we said is very important, right? The general form of the equation of a line, right? It's gonna look like this. Y is equal to mx plus b, right? So this is also important to know. And in this case, m, right, is your slope. B is your y-intercept, okay? And so these are sort of the main takeaways that we want to go over, right? And lastly, slope, just a reminder, is defined as rise over run, right? So this is the change in y over the change in x. And you can think about this conceptually as vertical change, right, over your horizontal change, all right? And so these are the main points of this lesson. So if you have any questions or comments, please add them below. But thank you for your attention and the opportunity to kind of teach you, okay?